Alright, so to finish this last two problems up, the top of the graph's at 3, the bottom's at -1. So that's 2 divided by 2, which is 1. So that's where the midline is. So the midline's at 1. So the equation is y equals 1. And then the last one, top of the graph's at 5, the bottom's at 3. So if I add those together and divide by 2, the midline will be at 4. In problem 8 and 9, it's asking you to sketch the graphs for 8 and 9. I might recommend to you, since this is one of the first types of activities like this, you may want to sketch sine theta first for both 8 and 9, and then think about what does the 2 and the 3 are going to do to the graph. And then turn the video back on when you're ready to continue. So the first graph, if I do sine, so at 0 it's 0, pi over 2 it's 1, pi is at 0, pi over 2 is -1, and then we're back to 0. So for sine theta, the graph looks like this. And that would also be true for problem number 9 as well. So I'm going to go ahead and sketch that one while I'm doing sine theta. Alright, so for problem 8, what the multiplication is basically saying is that whatever the answer is, it's now 2 times bigger. So here it's at 0, so it's going to stay 0 because 0 times 2 is 0. At pi over 2, the answer was 1. Now, if I double that, the answer is now 2. At pi, the answer is going to still stay 0 because 0 times 2 is still 0. At 3 pi over 2, the answer is -1. So I'm going to double that. Now it's going to be at -2. And then back to 2 pi, it's 0. If I double 0, I still get 0. So for 2 times pi, this would be the graph. Now, if I would put in, let's say, another equation of, let's say, f of theta is equal to, let's say, 5 times the sine of theta. So basically what this means is that every answer now is going to be 5 times bigger. It's kind of like when we did the ordered pairs and we changed the radius from 1 to 5. All those ordered pairs got 5 times bigger because the radius changed. So again, 0 is still 0. At pi over 2, I'll put 5 up here. The answer is going to be 5 now. At back to 0, pi, and then at 3 pi over 2, we're at -5, and then we're back to 0. So 5 times sine theta, the graph looks something like this. For the second problem, number 9, so what the addition of 3 means is that whatever the answer is for sine of theta, the answer is now going to be 3 more. So at 0, the answer was 0 for sine of theta, so that means for sine theta plus 3, the answer is going to be 3 more. So that means the answer will be at 3. At pi over 2, the answer was 1, so that means it's going to be 3 more than that, which means the answer is now going to be at 4. At pi, the answer here is 0, so if I go 3 more, that means it's going to be, pi is going to be at 3. 3 pi over 2 is at -1, so it's going to be 3 more than that, that's going to be at 2. And then the last one, 3 more than 0, means we're back to 3. So this would be the graph when you take sine theta and you add 3 to it. Now, the part that's really critical here, going back to a previous work, with problem number 4, for example, we have here a multiplication problem, and the multiplication problem actually creates what's called the amplitude. That's how much the graph is being stretched in both directions. We came down here to midline, which is problem number 7. Basically, the midline is where the graph is being basically split in half. So keep that in mind. So we go back to the problem here, in problem 8. What you need to understand is this graph is being stretched. So
if I would draw in the midline here, so I'm going to use the purple graph. So the top of the purple graph is at 2, the bottom is at -2. So I'm going to take 2 plus -2 and divide that by 2. The midline is at 0. And so the stretch here is going to be 2 up and then 2 down from the midline. And that 2 is the number you're multiplying. Now in the second problem, if I take the top and bottom here, which is 1 plus -1 divided by 2, the midline is again at 0. But in the second problem with the +3, the top of the graph is at 4, the bottom of the graph is at 2. So that would be 6 divided by 2. So the midline is going to be at 3. So what ends up happening is that the point here, which the zeros are actually in the midline. Now, for the second problem, the number that's on the midline is 3. So the +3 actually is how much you're driving or pushing the graph up or down, and that actually is also the midline. Where up here, the multiplication we're doing is actually called the amplitude, going back to the work that we did earlier. So a problem here, in problem 1011, what we need to consider here is what's the midline and what's the amplitude. And if we know those two things, then we should be able to hopefully finish off the equation correctly based on those two numbers. So, what is the midline and what's the amplitude for the graph? And then, where will those numbers show up in this equation? And then go back and look at the previous problems and see if you feel like you put the values in the right place. And then check your answer out in that Desmos problem 11 sketch to see if you did it correctly or not. So I'll turn the video back on when you're finished, and hopefully you feel comfortable in your identification of the midline amplitude and also final equation. All right, so top of the graph is at 40, the bottom of the graph is at 20. So if I add the 2 and divide by 2, that's 60 divided by 2, which is 30. So the midline is at 30. And again, like the previous problem we talked about, the midline is how much we're sliding the graph up and down. So this graph here was originally here at 0, and then it went up 10, and then back down, and then down 10, and then back up. And the reason I'm saying it's 10 is because from the midline, which is at 30, up to the top of the graph, which is at 40, that value is the amplitude of the graph. And so in both cases here, the original graph and the one I just sketched, the amplitude is going to be 10 in both of them. And the amplitude is actually what we are multiplying by to make the answer 10 times greater than it's supposed to be. And this, again, this 30 here is the midline. So hopefully you put the numbers in the right place in the equation. So the equation here is, this is the graph of that equation, and then what we're asking you to do here is change the values of the midline and the amplitude. This is more of an investigation, so for example, if I would change the number here, 1 to something else, and if I change that 0 to something else, can you predict where the graph is going to be? So this is more of a change the values. Let's see how well you are at predicting where the graph would be located at. And so again, go ahead and do that. I have scaled it from basically -5 all the way up to like 50. It looks like. So try to choose numbers that will get the graph in the region that is being shown on the decimal sketch. When you feel like you have got a pretty good handle on the writing these equations and predicting where the graph is, then please return back to the activity. All right, so what I'd like you to do to finish up this activity,
I have two equations here. I change sine to cosine. And if you could maybe sketch or write in your own words what you think the equations will look like for both situations, and then turn the video back on. You're done with that. From here, you'll go back to actually a delta math activity where you're going to practice writing equations involving amplitude and midline. And then the final activity is a Unit 5 review. And that activity will be due for your next class, because again, I'm trying to finish up Unit 5 and kind of do some things in Unit 6 in preparation for your upcoming test, which I believe will be at the end of next week. So, write down your ideas, kind of sketch the graph, turn the video back on when you are finished. Alright, so for this one here, if I would kind of put in the main values, so pi over 2, for example, pi, 3 pi over 2, and 2 pi are the main values. And so the graph itself for sine would, we'll put it in 1 right here, would go up to 1, down to 0, down to -1, and then back up to 0. So the graph looks something like this for sine. So what the 15 is going to do is it's going to take the number right here at 0 and it's going to move it up to 15. So the midline, which starts off at 0, now the midline is going to be at 15. So that's what this does. It slides the graph up 15. What the 8 does, it takes the answers and makes them 8 times bigger than they're supposed to be. So if I slide this graph up 15, then the graph will look something like this. So it'll go up to 16 here at pi over 2, back down to 15 at pi. It'll move down to 14 at 3 pi over 2, and then back up to 15. So this is what happens when I just do the add 15. So when I do the multiplication of 8, that means the answers are going to be 8 times bigger than they're supposed to be. So at 15, it's still going to be 15, because when you multiply this by 8, it's not going to change the answer. But if I go to the one here where it's actually, let's say it's 1, well, that 1's now going to become 8. So that means we are up 8 from where we were originally. So that means this graph's going to bump up to 23. It's going to be 8. The amplitude here is going to be 8 times higher than on the midline than it was originally. And then we're back to 0. And then here, we're going to be 8 below. So that takes us down to 7. So that point will be down here at 7. So the graph will start at 15, go up to 23, back down to 15, down to 7, because you've got to subtract the 8, and then back up to 15. So where the midline is, which is at 15, the amplitude will take it, the values 8 above and 8 below, where they would have normally been 1 above and 1 below. For cosine, what's going to be different is the graph itself is different. So we start at 1 at 0 instead of 0. And then we have pi over 2, pi, 3 pi over 2, and then 2 pi. So pi over 2, the answer is 0. At pi, we're at -1. Then 3 pi over 2 is back to 0. And then 2 pi, we're back to 1. So the graph kind of looks like this. So what happens when we subtract 1, that means the graph is going down 1. So we're going to go, this is going to be from 1 down to 0, from 0 down to -1, from -1 down to -2, from 0 down to -1, and 1 down to 0. So the graph is going to look like this now. And then, so the midline now is at -1. So what ends up happening here is the graph now gets stretched. So where the answer was at -1, now it's going to be at -2. Where the answer was at -2, now it's at -4. This will be at -2, and this will be back to 0. I'm going to stop because we're running out of time video, but just understand that we're going to multiply this answer by 2.